Hello, my name is Nakul, and I'm going to be talking about payload and recovery devices. A payload is a weight that the rocket carries during the rocket's flight. There are different kinds of payloads, as shown in the next slide. The first one of payload I'm going to be talking about is passive payloads. The passive payload is just a different kind of weight on the rocket to pose a challenge to the rocketeer. The next kind of payload is the optical payload. An optical payload has one purpose, and that's for cameras. So cameras so that you can record the flight of your rocket and test your dynamic stability, which my friend Yunal is going to be talking about later. Next is electronic payloads. Electronic payloads are payloads that collect data for the rocket. An example would be an altimeter or a chute release. When having an electronic payload, you need to make sure you have a section for it so that the electronic payloads are safely stored. Next, we're going to be talking about biological payloads. Biological payloads are the most ones you have to be most careful with, because biological payloads, you're handling with life here, and you need to make sure they come back alive. So don't use biological payloads unless you're under a supervision of like a giant rocketry organization like NASA or SpaceX, or you're conducting serious science experiments. Lastly, we need to talk about special payloads. For now, it is a format this is for like rocketry competitions. In our rocketry competition, we're going to be carrying 2 of these, and we have to get them safely back down. Now, how do you protect your egg? Because there are many different ways. There are different ways you can do it. You can put it in a small cushiony container, like here, and you'll put it inside your rocket and have a specific section for the payload. But these are not the only methods. You can be creative and have your own methods and test them. Now that you know how the 90 worked so hard to get the payload to the apogee, you don't want it to dive straight down and break the payload. You want it to slowly come down with the recovery device. These are the different variety of recovery devices. The first one I'm going to be talking about is a streamer. A streamer is a long piece of nylon fabric that flaps around in the air to produce lots of drag. Next is a helicopter. A helicopter deploys just like a parachute and releases 3 rotating fins that produce lots of drag to slow down the rocket and gently land. Next is a glider. It's a very unique design that when it reaches the apogee, it comes down slowly to the ground and glides down as if an airplane landing. The glider, side note you need to keep in your mind is that you need to have a really big field, because the glider is going to come down really far and slowly come down. Lastly, but not least, it's the parachute. The parachute is the most common and the most effective way to slow down a rocket. It's the what we're going to be talking about the most. These are the different parts of a parachute. The parachute has a peak, a canopy, the skirt, which attaches the shroud lines to the canopy. The canopy is usually made of nylon, but trash bags work great. The shroud lines are usually made of cotton, but for high power rockets, you need to make sure you use Kevlar. Now, how many shroud lines should you have? That depends on your shape, because your canopy can be made in a circle, hexagon, or an octagon. Now, if you have a hexagon, you might want to have 3 shroud lines. If you have an octagon, you want to have 4 shroud lines. And for a circle, you would have 3 or more shroud lines. Now, the shroud lines can't be too short or too long. So you want to have at least 1.15 of the diameter for each shroud line. Now, so now that you know all the parts of a parachute, you need to calculate how big the parachute should be. So these are the different ways to calculate it. The first one I'm going to talk about is the velocity. The velocity is the rate of descent your rocket's going to be falling down. And you find the velocity by your distance divided by time. Now that you know the area, now that you know the velocity, you can solve the area. There are 2 main factors and that can change in the area is the mass and the velocity. Those are the main factors of how much area your parachute, how big your area should be. Now if you go to the next slide, now that you know all the diameter, now you know the area, you can solve for the diameter. because you can't just take a long string and that won't produce enough drag. So you need to have the diameter so you can make a type of parachute. Now you might be wondering, what are the different pros and cons for different kind of shapes? They're all pretty much the same because they have the same area, so they'll slow down similarly. But the circle produces the least amount of drag, least amount of space. So it's just conserving space, so that's the only difference between all of them. Next slide. In the next slide, what attaches the parachute to the body tube? Because as shown in the image, there's a small line that is attached to the parachute. And that line is called the shock cord. This is very important because in the ejection chart, it pushes the parachute out, but this thing absorbs all the shock and it makes sure that the shaft lines don't rip. And then the next slide, we're going to talk about the different methods. So for low power rockets, you have a elasticy, stretchy rubber shock cord that can absorb the shock and come back. It would be attached like this. And now for high power rockets and mid power rockets, it's a different story. For high power rockets, you'll be using Kevlar instead of stretchy rubber, and you would attach it to the motor mount assembly instead of to the body tube. But one thing you need to keep in mind is that don't make the entire thing out of Kevlar, or since you're using high power rockets, the materials cost a lot and you want to reuse them. So if your nose cone pops out at the wrong time, the Kevlar is going to pull down and then the body tube is going to rip. So you want to make sure you have a cotton for the rest of the shell line. Now, how long should you make your shell line? For low power rockets, you want to make it double your body tube or 2 feet long. For mid power rockets, you want to make it 4 feet long, but for G motors, specifically, you want to use 6 feet long. Now for high power rockets, you have to make it 3 times your body tube length, but there are different calculations, and they may require further calculations if your rocket's complex. But 3 feet is the average. 3 times the diameter is the average of how long your shaft line should be, as shown in the image. Now, thank you for listening to my presentation. Now that we know all about the recovery device and payload, now you want to make sure your flight and apogee releases perfectly. Now my friend is Luliana, and you now are going to talk about stability.